Discover the three fundamental ways heat moves through matter and space. Heat transfer is the movement of thermal energy from one object or substance to another, happening in three main ways. Let's start by understanding what heat transfer actually means. Heat is the transfer of thermal energy from a hotter object to a cooler object until they reach the same temperature. A fundamental principle is that heat always flows from hot to cold, never in reverse, without external work. The first law of thermodynamics tells us that heat equals change in internal energy plus work done. Heat flows from the hot object to the cold object, driven by the temperature difference between them. The first method of heat transfer is conduction, which happens through direct contact. Conduction occurs when heat transfers through direct contact, as vibrating molecules collide with neighboring molecules. Conduction is most common in solids, especially metals, which are excellent heat conductors. The rate of heat conduction is proportional to thermal conductivity K, area A, temperature difference, and inversely proportional to distance d. In conduction, molecules vibrate and transfer energy directly to their neighbors through physical contact, like dominoes passing energy along. A classic example is when a metal spoon in hot coffee becomes hot as heat conducts through the metal from the hot end to the cold end. The second method is convection, where heat transfers through fluid movement. Convection occurs when heat transfers through the actual movement of fluids, either liquids or gases. Hot fluid becomes less dense and rises, while cold fluid becomes more dense and sinks, creating a circulation pattern. This diagram shows convection currents, where hot fluid rises on one side and cold fluid sinks on the other, creating a continuous circulation loop. Examples include boiling water in a pot, ocean currents that distribute heat globally, and weather systems driven by atmospheric convection. The heat transfer rate in convection equals the convection coefficient H times surface area times temperature difference. The third method is radiation, which is unique because it doesn't require any medium. Radiation transfers heat through electromagnetic waves that can travel through empty space without needing any material medium. Radiation is the only heat transfer method that works through a vacuum, which is why we receive heat from the sun. Radiation emits electromagnetic waves in all directions from the heat source, traveling through space at the speed of light. The Stefan-Boltzmann law states that radiated heat is proportional to surface area times temperature to the fourth power times the Stefan-Boltzmann constant sigma. Examples include the sun warming Earth across 93 million miles of space, infrared heaters, and feeling warmth from a campfire. Let's compare these three heat transfer methods side by side. Here's a comparison showing conduction works through direct contact in solids, convection through fluid movement in liquids and gases, and radiation through electromagnetic waves needing no medium. Let's explore how these heat transfer methods work together in everyday situations. When cooking, conduction heats the pan bottom, convection circulates hot air in the oven, and radiation from heating elements adds direct heat. Home radiators heat nearby air through conduction and convection, while also emitting infrared radiation across the room. Earth's climate system involves radiation from the sun, convection in atmosphere and oceans, and conduction at Earth's surface. This cooking pot demonstrates all three methods: conduction through the pot bottom, convection currents in the liquid, and radiation from the heat source below. Let's summarize what we've learned about heat transfer. Heat can transfer through three fundamental methods: conduction by direct contact, convection through fluid movement, and radiation via electromagnetic waves. Each method has its strengths: conduction in solids, convection in fluids, and radiation across empty space. In most real situations, multiple heat transfer methods work together simultaneously to move thermal energy. Understanding these mechanisms helps us design better insulation, heating systems, and energy-efficient technologies for homes and industries.